All right, so we're back. So let's work on some practice problems for this section, right, to illustrate some of this, because I know a lot of it's vague, but it's better if we see it, what actually happens, right? So let's start with 5.14 on page 219 in the 4th edition. So this one is pretty simple, and so it's asking if we had a single digit from 0 through 9 is selected using a software random number table, right? So this is 0. And so the first one that's asking us is A, state the sample space for all the possible outcomes, right? And so if we did that, it'd be 0 is 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, right? Pretty easy. And then for B, state the probability for each possible outcome based on what you know about the way random numbers are generated. So we're assuming they're independent, that there's no dependency between it, right? And since there are 10 numbers, right, there is a 1 out of 10 chance of a number being selected. Right? Pretty simple, right? And then if we look at number C, we know that one of the rules of probability, right, is that each outcome in the sample space must have probability between 0 and 1, and the total of the probabilities equal 1. Show that your assignment of probabilities in part B satisfies this rule. So if we add 1.1 times, we did that 10 times, right? We added all those 1/10ths up. This would equal 1.0, right? So hopefully that seemed pretty easy and not too difficult, right? So let's see here. What would be like a good one to do, right? I'm trying to think about what I assigned for you guys for homework and then what I didn't. So let's see, what would be a good one? I don't know, I guess we'll do 5.15, right? So we'll do a new one. We'll do 5.15, say this is on page 220. So this question is asking a teacher gives a 4-question unannounced true-false pop quizzes, right? So there are 4 questions. And these are true TF, right? True, false. 2 possible answers to each question. We already knew that, right? And so I don't care about the tree diagram. I'm not going to ask you to do that. But we look at B. It says an unprepared student guesses all the answers randomly. Find the probabilities of all the possible outcomes in the tree diagram. So we know if there are 4 questions, right? So for Q1, and then Q2, and then Q3, and then Q4, we know that there's 2 outcomes here, 2 outcomes here, 2 outcomes here, 2 outcomes here, right? And so it's asking us find the probabilities of the possible outcomes on the tree diagram, right? And so how would we solve this, right? So the first thing that we would do is multiply these. So 2 times 2. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So there are 16 outcomes, possible outcomes, right? And the probability of one individual outcome, right? So the prob of one outcome, not any one in particular, mind you, but just one outcome is 1 out of 16, which is about 0.0625, right? So hopefully, like, pretty easily, right? So refer to part B, and then if we look at, so that was part B that we just solved here, so we'll say it's B. And if we look at a different color, we look at C. It says, look at the tree diagram that we didn't draw. there are 5 outcomes, or excuse me, evaluate the probability of passing the quiz, right? Which, so passing the quiz, which the teacher defines as at least 3 questions correct. So if we looked at like all these outcomes, right, there are like 5 possible ways you can do it, right? So, I mean, you could do the tree diagram, it doesn't matter, right? So if we're looking at least 3, then we need to list out all the outcomes in a sample space, right? So if we're looking at 3 of these, right, what would we do? So we know one way to pass, right, is if we got correct, 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 incorrect. So this is a pass, right? We would also know that there is correct, correct, incorrect, correct. This is also a pass because there are at least 3 questions that are correct in order to pass, right? There's correct, incorrect, correct, correct. There's also incorrect, correct, correct, correct. And then since it's at least 3, we also know that there is all correct, 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 right? And so the probability of each one of these happening, we already know these are 16 outcomes, right? We know the probability of this occurring is 0.0625. The same is true for this one is equally likely. So is this one, and so is this one, and so is this one. So the way what we end up doing then is that we would do add up all these probabilities. So we do 0.0625. We could do it times 5, right, if we wanted to be simple, but we'll just, let's say we add them all up, plus 0.0625. And this is going to equal about 0.03125, or if you rounded, it'd be 0.313, which means there's about 31% likelihood of passing the exam, of passing combos. So that's what we're getting with that one. So hopefully that one is making sense. So let's do a little different one, right? So I don't know. Do you guys want to do newspapers? Do you want to do? We'll do the newspaper one, just cause, right? And so just so everyone is on the same page, this is going to be 5.26 on page 221. So it says you are the director of newspaper sales for the local paper. Each customer has signed up for either a weekday delivery, so we know that there are weekday deliveries, or weekend, so a weekend delivery. You record whether he or she received delivery as a yes, so we know there is a yes, and we know that there is a no, right? So the probabilities of the customer receiving the newspaper are as follows, right? And so we're just using the information that's provided in here. So we'll look at the outcome. So the outcome of yes, they got it on the weekend, and yes, they got it on the weekday, equals 0.25. If we got it on the weekday, but not on the weekend, this is equal to 0.05. If they were no on the weekday, but yes on the weekend, this is equal to 0.20. And if they did not get delivered on the weekend and not on the weekday, right, This is 0.5. So really important to note here, right, is that we listed all the sample space outcomes here, right? So let's look at part A. So what are we being asked to do in this question? So in this question, it says display the outcomes in a contingency table. This should sound familiar. We've already done this in the course. And so you should maybe flip back or look at your notes again and use the rows as the weekend event and the columns as the weekday event. And then what does this look like, right? So we have, let's say we have this, right? So we have WE, we'll call this the weekend. And up here, call it the weekday, right? So we'll get this, we'll do that, right? And we'll clear this up, or let me tidy up real quick. We'll just move this down a little bit. We'll use, okay. So we have the weekend. And so we have different color. We have yes on the weekend. And then we also have no on the weekend. And then up here, back to our purple, we have the weekday, right? And then we have yes on the weekday. And we have no on the weekday, right? So if we make our little pretty table, contingency table, we do that. And we do this. And so let's fill this in. So if we look at what exactly we did, so we saw the weekend and the weekday. So we know that double yes right here is 0.25. If we look at yes on the weekend, right? So on this first one, right? But no on the weekday, this is going to be 0.05. Oh, I'm sorry, excuse me, got that password. Whoopsie. So no on, so yes on the weekend and no on the weekday. This is, wait, did I get, oh yeah, that is right, 0.20, right? If we had no on the weekend, but yes on the weekday, this is going to be 0.20. Wait, I keep getting that jacked up. Whoops. All right, anyway, so this is 0.05, and then the double no's are 0.5. Sometimes it's easier to do this and this because we know those are in, right? And so if we look at, wait, did I look at this? I had them mixed up, right? Whoopsie. All right. So yes. Oh, sorry. So these are tabulated as, yeah. So weekday. Oh, I put it in wrong. That's why. So on the weekday, anyway. This is correct. Just trust me on this, right? So on the weekend, probably should have been yes, and then no's on those. So these are the 4 total outcomes, or 4 like characteristics that we create this probability that's happening, right? So if we create this total, so this is going to be what? We know this is 0.45, this is 0.55, 0.30, and this is 0.70, right? And these all sum up to 1, right? So we know that we have at least got that part correctly, right? So part B is asking us, let's get back to our color. So B, let W denote the event that the customer bought a newspaper during the week. So W is during the week. And S be the event that he or she got on the weekend. So S is on the weekend, right? So this is the weekday. And this is the weekend. So fine. So then the question is asking us, what is the probability of getting the weekend paper and the probability of the weekday paper and the weekend paper, right? So this is and, right? So this is the intersection, right? So if we look at our fine little chart right here, where would we easily find? We see this answer is right here. So the weekend and the weekday, and this is equal to 0.25. Now, let's go to a different one. So we look at C, right? Or wait, we already, So yeah, we did that, right? Oh, excuse me. I actually solved C. Sorry. So this is C. Oops. So that's the intersection, right? So we both find, right? But probably D and S. So if we looked at B, it's asking us denote the event the customer bought a newspaper during the week, and S be the event that he or she got it on the weekend, right? So what would this be? So the probability of W. So probability of getting that happen. So all the ones where there's the weekend, right? There is 0.25. And also 0.1 equals probability of 0.3. And the probability S is going to be equal to the probability of 0.25 plus 0.20, which is equal to 0.45. So then D is asking us, are W and S independent? Events explain why you would normally not expect customer choices to be expected. So if these were independent, we would expect that the probability of W and S equals the probability of W times the probability of S. And this would equal 0.3 times 0.45, which equals 0.135. But we also see that this is not the case because in the table we look above, right? So we look back here, it's actually 0.25. So these are dependent events. So people who buy on the week and also buy on the weekday. On weekday, because they like the paper. All right, so we'll call it there. Hopefully those were useful. Make sure to work on the practice problems and look through some other problems in here as well.